In the last lecture, I explained to you that interfaces got nothing to do with inheritance. But interestingly, they do provide polymorphic behavior, as we learned in the section about polymorphism. So in this video, I'm going to show you how we can use interfaces to achieve polymorphism. Let's get started. Okay, in this project, I have got a class called video encoder that is responsible for encoding a video. It has a simple method called encode, which gets a video object. Let's take a look at the video encoder class. Here's the encode method. For simplicity, we don't have to worry about the video encoding logic. But what is interesting here is that once the video is encoded, we use the mail service to send an email to the person who uploaded that video to our website. Let's take a look at the mail service. So again here, to keep things simple, we are not worrying about how to send an email, we just log in a message to the console. Let's run the application. So we are simulating that a video was encoded and we sent a notification email to the person who owned the video. Now, let's get back to video encoder. There are a couple of problems with this class. The first one is this type dependency to mail service, which is going to affect the testability of this class. So earlier in the lecture about testability, we learned that if we want to unit test the class, we have to isolate it. So instead of using a concrete mail service here, it would be better to send an interface in the constructor and initialize an iMail service field here. But that's just one problem. There is another problem. The problem is if tomorrow we decide to have another way to notify the person who owned the video, let's say send them a text instead of a mail, or maybe both, then we have to come back to this method and change it. Which means every time we change this method, the class that contains it has to be recompiled and redeployed, and any other classes that are dependent on this video encoder, again, has to be recompiled and redeployed. And as I've always said, as software engineers, we want to reduce the impact of change in our software. So earlier in this section, I introduced you to the open-close principle of object-oriented programming. Just to refresh your memory, open-close principle, or OCP, states that software entities should be open for extension, but closed for modification. Now, we're not going to apply this principle everywhere, but there are areas in our system where we see there is potential for change. Like in video encoder, we know that potentially we could send a text message to the user, or maybe we would notify them as they're online on the website. So here is an area that is going to be affected as a result of that change. Now, how can we implement open-close principle using an interface here? Well, first of all, when we design this class, we should not think about mail service. We should think in abstractions. We should think when video encoder does its job, it needs to send a notification to the user who owns the video. How? We don't know. We don't know what kind of notification. We don't know if it's a mail or a text message or a real-time notification. So video encoder should not know about that. So in this class, we need to think of a notification channel as an abstraction. And that's where an interface comes in. Because interface is just a role. It's a contract. Again, remember the example about a restaurant and a chef? A restaurant is a chef. Anyone who can fulfill that role based on some standards can be a chef for that restaurant. We don't want the restaurant to be tightly coupled to John or Steve. So same here, we don't want the video encoder to be tightly coupled to a mail notification service. So let's see how we can use an interface to implement open-close principle here. First, we define an interface. Let's call it iNotification channel. Again, this is an abstraction. We are not talking about mail or text or whatever. Now, this is just a notification channel. We want to send a message to that channel. So here we need a method like void send, which gets an argument of type message. Let me create this class. So I move this class to a separate file. Back to where we were, and same for iNotification channel. There you go. So it's a very simple, clean interface. Now, mail could be one notification channel, or SMS could be another notification channel, So we can create concrete classes that implement this interface. So let's create a new class here. Mail notification channel implements iNotification channel. Alt and enter. So for simplicity, let's just log a message on the console saying sending mail. We move this class to a separate file. Back to where we were. Let's create another class that implements this interface. This time, SMS notification channel. iNotification channel. Again, the same steps. Implement the interface, log a message on the console saying sending SMS. And we put this in a separate file. There you go. So we have one interface with two implementations. Now let's go to our video encoder class. So here we no longer need a reference to mail service. We should think in terms of a notification channel. But we could have more than one notification channel, right? Because at the same time, we may want to send an email and also a text message to the person who owns the video. So what I'm going to do is let's remove this field here. Basically, we need a list of notification channels. So private, read-only, iList of iNotification channel, and let's call them notification channels. Now ReSharper is detecting that I'm using iList, and that's a generic interface as defined in system.collections.generic. So you can click that or press Alt and Enter. So it adds the using statement on the top here. Again, if you don't have ReSharper, you have to manually type that. Now in the constructor, we need to initialize that list. So let's just initialize it to an empty list, new list of iNotification channels. Now, all we need to do here is once the video is encoded, we need to iterate over the notification channels and notify each of them. So we do a simple for each channel in notification channels, channel.send a new message, right? So in the video encoder, we are not talking about mail service. We're not talking about SMS. We're talking about abstractions. iNotification channel. Whoever implements that, that's none of our business. Video encoder is not going to be affected. We can create new implementations of that interface, and this class remains unchanged. So with this, we achieved open-close principle. Our software is open to extensions. We create new implementations of iNotification channel. And it's closed for modification. So this class is no longer going to be changed. Now there is just one step missing here. We need to tell video encoder about the actual notification channels at runtime. So how we do that is, because this list is defined as private, because it's implementation detail of this class and we don't want to expose it to the outside, we need to create a method here, a public void, let's call it register notification channel, which simply gets an iNotification channel parameter and call it channel. All we do here is we add that to our list, add channel. So this is the method we use from the outside. Let's go to the program class. So in the main method, after we initialize the encoder, we call that register notification channel method. And here we pass a concrete implementation of notification channel. So new mail notification channel. And we repeat that. This time, we use SMS notification channel. Now let's run the application. There you go. We got two messages. One is sending mail, one is sending SMS. And interestingly, we can create a new class that implements iNotification channel, and we just pass that here in the main. And as you saw, video encoder is not going to be affected. Now, the interesting thing here is that with interfaces, we have a polymorphic behavior. Let's go to video encoder. So when we are iterating this notification channels list, at runtime, when we call the send method, depending on the runtime type of that notification channel, a different method is going to be called. And that's what we call polymorphism. So at runtime, if the first element of our list is a mail notification channel object, the send method in the mail notification channel class will be called. This one. Get back here. Now, if the second element of the list is an SMS notification channel object, a different send method will be called. This one. So as you see, with interfaces, we can have polymorphic behavior, and that's very powerful. Now, there is also a different way to implement the exact same scenario in C#, and that is using events and delegates. And that's something that I have classified as advanced topic, which you can find in my C# advanced course. So in my C# advanced course, I introduce you to the concept of delegate, and I actually have a video on my YouTube channel called Events and Delegates, where I introduce the exact same problem, but use a different solution using an event and a delegate to implement that kind of extensibility. So in case you're passionate about learning all this stuff, that's an additional video you can look at. I hope you enjoyed this lecture, and thank you for watching.